Wow, how frustrating. I just made this video a second ago and then took 8 minutes to make the video and I was wrong. So I wanted to tell you that I went back, I looked at my work. You never saw it, but I looked at it and I'm pretty good at this and I screwed this up. So maybe that tells you that we're all just people. Anyway, moving forward, just wanted to remind you that there was a time actually when I was studying trig also, and I remember trying to memorize when are these functions, when are the six functions positive and negative. I didn't kind of think about why it's true. I just thought it's just easier if I just memorize it. And it turns out it's not easier. This really makes a lot of sense. Here's the Cartesian plane. Let's start off with the idea that we have quadrants 1, 2, 3, and 4. Then we have positive x, positive y, negative x, positive y, negative x, and negative y, positive x, and negative y. Think about that for a second, because if we agree that sine is equal to y, then every place that y is positive, sine is positive. So sine is positive. Sine theta is positive here, isn't it? And sine theta is positive here, isn't it? Because y is positive, so sine theta is positive here. So sine theta is positive. If it's not positive in a quadrant, then it's automatically negative. And it makes more than good sense because here sine theta is y, and y here is negative, and it's also negative here. So I'm just going to write that in if you don't mind. I'm going to write sine theta is negative here, and here, right, sine theta is negative here, isn't it? Okay, I think that makes good sense. I'm going to just move on to the next function. This is how I'm doing this. This is y, not what's true, but what y is true. And we know that cosine of theta is x, isn't it? So where x is positive, so is cosine of theta. So here, x is positive here in this quadrant, so is cosine theta. X is positive here, so is cosine theta, because cosine theta is x, so cosine theta is positive here. I think that's making good sense. Here the x values are negatives, and therefore cosine of theta, because it's x, is negative here. And the same thing for the same reason here is negative. Okay, so I think hopefully we're doing okay. Let's move on to the next, and now we have tan of theta. Let me change colors to something pretty for you, some orange. So tan theta is equal to y over x, right? So y over x. So when both y and x in the Cartesian plane are the same sign, then this will be positive. We'll have a positive over a positive, which is a positive. Or in the case of quadrant 3, we have a negative over a negative. So here we have tan theta. Tan theta is positive here. Tan theta is positive here. So far, so good. Tan theta, in the places where the signs are opposite, we have a positive over a negative, which is a negative, or a negative over a positive, which is a negative. So we have tan theta here is negative. Tan theta here is negative. I think we're doing pretty good so far. So let's keep moving. Let's take their reciprocal functions now. So for sine, right, the reciprocal of sine is cosecant theta, which is 1 over y. So the same thing is going to be true here. Same exact thing is going to be true here when y is positive, because 1 is always going to be positive. So the only thing that's going to change the sign is y. So anytime that y is positive, so cosecant will be positive. So here, cosecant theta is positive. And here, cosecant theta is positive. Here, y is negative, so let's be careful. So cosecant theta is negative here, and cosecant theta is also negative here, right? Now I'm going to just go to the next function. We have 4 of the 6 functions done. We're closing in on it, right? The reciprocal of cosine is secant. So secant theta must be equal to 1 over x, right? Whenever x is positive, right? The 1 in this thing will always be positive, so the only thing that's going to change the sign of it is going to be the x value. So if x is positive, so will secant. So here we have secant theta is positive because x is. Secant theta is also positive here. Here x is negative, so wow, I almost screwed that up. So secant theta is also negative. Secant theta is negative here, right? So where does that get us? We're doing pretty good. No, it gets us only, well, now we're to here. Finally, we're almost done. We're record time, record time. Remember that cotan theta is the reciprocal of tan theta, and as its reciprocal, it's the reciprocal here. So it's xy. Same thing is true when both are positive, so this will be positive. So we have cotan theta is positive here. Cotan theta is positive here. So let's see what we have here. Here, the only two that are positive are cotan and tan. That is true. Here, the only two that are positive are sine and cosecant. Looking here, right, signs are different, so cotan theta must be negative here, right? And here the signs are different, so cotan theta must be negative here. The way other people do, they just want to know when is it positive, because this is not positive in a place, it's negative in a place. Remember here, look, all of them are positive here, right? All positive. Here, the ones that are positive are sine in quadrant 3, in quadrant 2, just sine and cosecant. Everything else was negative. When we go to quadrant 3, the only two that are positive are cotan and tangent. The rest are negative. And lastly, when we get to quadrant 4, the only two that are positive here are cosine and secant. Yes, you can just memorize them if that's what you choose to do, but we can figure this out using the Cartesian plane in a little simple algebra. Okay, nice work.